All right. Who can tell me anything that you've learned so far about that periodic table? Okay, so what's important about atomic numbers?
Your protons.
Okay.
Then your
Okay.
atomic mass.
Right. So if we're talking about the atomic mass, what equals the atomic mass? Okay. Now, if you pick any element out on the periodic table, you have to have a whole number. For instance, like maybe even cobalt. If we were talking about cobalt 60, if we say cobalt 60, it's element 27. What can you tell me about the three numbers? Okay. 33 neutrons. Okay. 33 plus 27 would give you 60, correct? That's why we say cobalt 60. Why is it, when you look at that, what is cobalt's atomic mass?
59.
So why don't we just look at it in this fashion then? Okay? So when we're talking about cobalt, okay, why do we not have 59 point whatever?
It's like 0.99.
It is 0.99. Yes, we could round up. But why does that not work?
It just makes it easier that way you don't have point something.
You can't have a partial neutron. That's right. That's why you can't have 59 point whatever. Okay. But that's why we're rounding it up to 60. Oh, well, you could say cobalt 59, but there's also cobalt 60. We're telling you that. Is there any questions before we proceed forward? It is our job to help you. What would that be?
Wait, what are our worksheets going to be like? Are they going to have word problems?
Well, it depends what you can. Not story problems like last chapter. No.
We like more vocab.
You do Bohr models and configurations. What we've been doing all week, all last week. Okay. Is there anything that we've talked about so far that is not clear? I mean, and maybe you don't know what to ask, but yes.
Do we get our slide rule?
Well, you get a slide rule, but what good does it do if on your slide rule you have all the examples we've done? What does that?
You already have the answer, so.
Right. So then, is that fair for people? Just keep that in mind. If you have that, that's fine.
You have to work smarter.
But when it comes to the evaluation time, make sure that you've got a slide rule with that's all that's on there is the slide rule. Does that make sense? Okay.
So if you start the test, you can figure out all of them at once, right?
Well, then we're really not giving you a true evaluation. Okay? At least in my estimation. Okay. So, proceeding forward. How many vertical columns do we refer to on the periodic table? Be careful. Not 7. There's 8, okay? Always keep that in mind. The number 8, okay?
Wait, like going down?
No, vertical.
Vertical.
1, 2, 3, 4,
Okay?
6, 7, 8.
Now, you're going to tell me that there's 18, but
You don't count the D block.
you do not, you disregard the D block like you just said. That's correct. Disregard the D block. Okay? Now, with that being said, the reason you're getting that mixed up with the number 7 is why? Those are not columns, those are rows or what? Rows or what? Periods. There's 7 periods. That's the repeating pattern we're talking about. Okay. So, when you keep that idea in mind of vertical columns, the numbers 1 through 8, okay? Someone pick an S or P block element.
Nitrogen.
Okay, so nitrogen is in which column? Which column of the entire period? Let me ask it that way.
Wait, I can't even find it.
In the entire period, a horizontal row, the entire period, what column is nitrogen in? It's in the 5th column. That's always going to be important. Okay? Because should you have picked an S block element, someone give me an example of an S block element. Hydrogen. What column is hydrogen in? So, with that being said, what is this telling you then? Group 1 has what in common with any other element in group 1 or column 1? They all have this same characteristic in common. We illustrated that up on the board last week. What's it telling you here? They have 1 valence electron. What about if you pick magnesium or strontium or beryllium? Where's that? Right next door. How many valence electrons does it have? In column 2, so it's got 2. You said earlier, do what with the D block elements? You skip them, and then when we say nitrogen, you've got the 2 columns of the S block and the 3rd column of the P block. That's how you get the number 5. Okay? So a halogen is, for instance, iodine, fluorine, bromine. What vertical column is that in? Of the entire period.
Iodine would have to be in the good.
The 7th column. So therefore, if it's in the 7th column, how many of these would be in there, do you think? There would be 7. That's what we're talking about here. Valence electrons. Those are the ones in the outermost energy level of any atom. The valence electron. Valence or valence, however you want to pronounce that. Does everyone have this content that wants it?
Wait, let me see. Yeah.
Okay. I want to do this one, and then I just want to get through this slide, okay? And again, you have this handout because this helped me explain this content to you, okay? It's the best way that I feel is most beneficial for yourself. We're trying to make the best possible decisions for yourself, okay? So basically what this is trying to tell you, okay, that's why this slide rule is so important for yourself. It makes things a lot easier for you, okay? Does everyone have this content that wants it? Okay? Okay. So moving forward then, okay, I had noticed this. Any of you out there fans of Spider-Man Homecoming, Spider-Man Far From Home, and Spider-Man No Way Home? Has anyone seen the third installment or No Way Home? Okay? There's no way you would ever know this, okay? Because you just haven't been taught that. When you see the three Spider-Mans that show up and they're all working together in that lab, in the background, okay, on a whiteboard, you'll see structures, big diagrams like this. That would be one of them. Then
Looks like a butterfly.
these are different electron structures in the electron cloud for D block elements. I don't know why that's in the background of the movie, but that's what that's for. Because when it comes from what we call quantum mechanics, now there's 5 of these. I just put 2 of these down, okay? This gets to be a little more complex when you take general chemistry in 2 years, okay? Because when we talk about quantum mechanics, if you combine something like that to like Star Trek, where they say, beam me up now. Is that Star Trek? Does that sound familiar? What they're doing is at the microscopic level, all these electrons can be disassembled and put back together. Okay? But the problem is if it's not put back together correctly, you would no longer exist as that person. So it's really not that far off or that far-fetched. It's just that it's too dangerous to ever try something like that. So at the quantum level, how do these electrons and atoms behave? That's what they're illustrating here. It's just electron behavior. Because when it comes to any element, what determines how an element will react? Is it the neutron, the electron, or the proton, do you think? What have we spent the most time on? Well, it's either protons or electrons. You got a 50-50 shot. you would correctly say electrons. Why would that be? What have we done with example after example? You got an entire slide rule for this. It's not a slide rule of protons. It's not a slide rule of neutrons. It's a slide rule of electrons. That determines any element's reactivity. Okay, so now, if we had to do the Bohr model for cobalt, okay, we're doing cobalt. We did? Well, I thought it was chromium. Doesn't matter. Okay, pick another D block element.
Lead.
You want to go that big? Lead?
Yeah. Lead. Mercury. Lead.
Okay. We can. I think that's a little big, but we can do that if you so choose.
That's like 76. That's
Iodine. Yeah, let's do lead.
Okay, I like iodine. That sounds good. Is that right? Is it 53?
Yeah.
Okay. Now,
126.9.
okay. So we're going to say 127. What is everything you can tell me about that atom of iodine?
protons. 53 protons. I don't know, 120.
I'd have to.
53.
Your neutron is.
Is that right?
I'll make sure.
Okay. So now, when you get to be juniors, I can tell you. Do you want a little bit of insight to tell you whether you are right? Do you want me to tell you there's some predictions that you can make for this element? Do you want that little?
73.
You want that little hint?
74. Yeah. Would be, yeah, we want that.
But I'm afraid that what you could do is get that mixed up with D block elements. That's why you got to be very careful if you say yes.
Yes. Do it.
Okay. We can do that with this. What period, horizontal row, what period is iodine in?
5.
Okay, so we're going to see that number. In the entire period, all the way across,
17.
what column is iodine in? No.
No, sorry, you don't count the.
7, okay. And then what column in the P block only, is iodine in? Okay, we're going to see those three numbers come back again. And this is why. Follow your slide rule. Okay, what does that tell you? 1s,
2.
okay?
2, 6.
Then what?
2, 6, 10.
You're right, but don't do it that way. I know you're right. Whoever said 2, 6, 10, don't do that.
That's me. No, it's the same.
Okay?
But it's,
Well, you have to do your third.
Okay? Well, let me explain it this way. Okay? Through the course of a game, I want to do one of these behind the back passes. The coach tells you don't do that. So what do? Do you continue to do it then?
if you're wide open,
Probably not.
do it again.
Probably not. So if I'm asking you don't do that, what does that tell you? Please don't do that. Okay. So this is the third energy level. What block is this? It's a letter. What letter? S block. 3s2. You keep going. 3p6. Then what?
4s2.
Okay.
3d10.
See, I was right.
Yeah, dude. Good job.
4p6.
That's solid.
5s2.
2, 6, 10, 14.
4d10.
Oops, I'm getting a little ahead of myself. Okay. Then what? Someone said it. It's 5p what? Right? Okay. Those predictions that you can only do that for S block elements and P block elements. Do not ever do this until you got a very good understanding of this concept. Okay. What we mean by this is your first energy level. There's your second one. There's your third, fourth, there's fifth. There's that 5. Okay? Where do you suppose that 7 comes from? 2 plus 5 gives you what? There's your second one. Okay? And what column in the P block only is iodine in?
Where does the
There's your third one.
Mr. McKinney, where does the first 5 come from?
Fifth energy level. Okay?
At least it's not in the 7th
All right.
column.
Well, I wish it was.
If you choose to do that, you can make those predictions on S and P block elements. No. Okay, that is a Bohr model. Then, if you really want to help yourself for when you do this again in 2 years, the last set of electrons that you put in, put a box around it. Okay? You don't have to. I'm not looking on your papers to say you didn't put a box around the last set of electrons that went in. I'm not looking for that. But some of you, if you want to have that little extra little bit of help for when you are juniors, this gets to be more important because this tells you your quantum numbers. You don't need to know quantum numbers right now. That is not till you take junior level chemistry. Okay. Is there any questions on this?
You mean like 1 and
No, sir.
With the knocking on whatever it is we're doing, please stop. Okay? Is this pretty straightforward for you? It's a little bigger. It's a little more difficult. Now, we're going to do the configuration for this. Is new material. Okay? So, also, how many valence electrons does iodine have? Why are you right? It's in the 7th column. We just illustrated that. Electrons in the outer energy level. That's where that comes from as well. Okay. Don't write this part down. Okay? A configuration is just a linear depiction of this. Really, when you look at an element, you should have like electrons going around like this. Like when we were watching that video, these electrons are rotating around in the cloud structure. It's just much, much easier to write it out like this. Because really, these are going around the entire nucleus. But you got the same information here, you're just putting the numbers in rather than circles like this. Does that make sense? Okay. So now we're going to do this linear depiction of iodine. Okay? So what that means is this here. We've got 1s2. Okay, so if we've done this correctly, all of these exponents are these numbers that you see here. Okay? Please stop that. Okay? All right. So if we add these together, we've got 10. Okay? We've got, okay, here is another 10. Okay, there's another 10, 8, 18, and 5. Okay, 10, 20, 30. Is that math correct? Okay, so a configuration is just a linear depiction of all of these numbers we just put in. That's all it is. That's a very good question. The answer, you can take a shortcut. Makes things a heck of a lot easier. You can do it this way too. This makes it more difficult. But this is difficult. I got a much easier way to show you than this. But maybe we don't like things the easy way. We just like doing things the hard way. Easy way? Well, not everyone raised their hand, so we must want to do it the hard way. So, why didn't they raise their hand? I don't know. I don't know. Just a good enough answer as anything, right? Okay. What this means is this, okay? How many of you, can you take Algebra 2 as a freshman? No. As a sophomore, you can. Do you do factoring in Algebra 1? What I mean is this, okay? Let's say you had, don't write this down either. Let's say you had 3x squared plus 9x plus 3. What do those all have in common? The number, okay? So we can factor a 3 out of there. In other words, 3 times x squared plus 3x plus 1. Have you ever seen anything like that before? No. Someone says yes.
No. No, we have not.
First time I've seen it was right now.
Someone said yes over here. Okay? This is a way of simplifying that, because what happens, what's 3 times x squared? 3x squared. What's 3 times 3x? 9x. What's 3 times 1? So you can get the same answer. It's just simplifying it. Okay, so what you can do is this. Okay, we are going to do, let's say, do manganese, because Minnesota ended up on a high note yesterday, right?
Yeah, they got that coach fired.
I don't know if he's fired or not. Okay. So, now, if you write this part down, fine, but I would suggest that you don't. Okay? It's 25, right, for manganese?
24.30, that's going to round down.
What's the atomic number for manganese? It is 25. Okay.
Hey, you need to tickle yourself.
Okay, Mr. McKinney is whatever. Oh my gosh, stop hitting.
I thought we were doing magnesium.
Okay. We've got 10, 18, 20, 25. You add those exponents together, you get 25, right? Okay. Can anyone tell me what is so significant about neon, argon, krypton, xenon, and radon? What column are they in? They're all what?
They're all on. No apple. Right on, argon.
No.
They're all in the
They're all in
What? They're all in some deal.
What column are they in?
The first, 7. The 8th.
The 8th column. That is important because these elements are highly stable. That's why they're noble gases. Okay? So what this means is, let's look at the element argon, because that's a noble gas, right?
Yeah.
Let's look at this here. 1s2.
It's got an even number of protons.
Oh, that's true too.
You missed me.
Do we see anything similar to that electron configuration for argon and electron configuration for manganese? This is what I mean. Okay? So, what do you notice about this if I put this in a box like so? Those are the exact same things. Okay? So what that means, to simplify that, remember we factored that 3 out of 3x squared plus 9x plus 3? You factored that out of there. This, you are factoring this out of here to make this much, much easier. Look at how much we have left when we just factor that. Okay? So what that means is, if you want to take a shortcut, which I suggest that you do, means you put this inside of brackets. Okay? Then what comes after this here? What do we have left? What do we have left? Then what? What happens when you add that number, and that number? What do you get? 25. So for any element, you can use a noble gas configuration and make things much, much easier. 18 plus 2 plus 5 gives you what? So that's what we're accounting for. This and this mean the same thing. It's the exact same configuration. You're just taking a shortcut with this one.
Then what about the other thing I'm replacing?
We can do a shortcut for this one too. What you have to do, pick, you got to go down in number. So what is the next lowest noble gas from element 53? We can't use 54. That's xenon. That's too big. So 36. What element is that? Okay? So we've got krypton. Okay? Then, remember we said you could put the periods along the side here, right? Find krypton. What period is krypton in? 4th, right? Okay. So after you fill 4p6, what comes on this side then? What comes after 4p6? 5s. Okay. Keep going in your slide rule. What comes next? Then what? What column is this in the P block? What is 5, 10, 7, and 36 equals what? It does? It should. 15, 17, and 36. That's what you're supposed to get.
36.
Okay? So, in other words,
How do you know which ones to do?
you got to go down in number. You can't go up.
So you can go like down to any number.
You can. You could even use neon if you wanted to.
So if you use like
But it has to be in the same block.
whatever that.
It has to be in that 8th column.
Wait, if you use like
Exxon or whatever, and then you have to use radon.
If you're dealing with numbers that big, but that's why I'm saying 53, you have to go down. You can't use xenon. That's too big. You have to go down in number. With that being said, okay, what What period is krypton in? You said fourth, right? Okay. So that must mean that we've factored all of that out of there. What is outside that box? Same thing we put down here, right? Noble gas configurations are much, much easier. Do you feel you need to see it? Who has a pretty good understanding of this? Chair down, please.
How can you use 36 and column? That's not in the same column. You said they have to be in the same column.
What I'm interpreting, you're saying the same column is all the noble gases. That's why I interpreted your question.
Why can't you use neon?
Well, you can. But let's say you did neon. That means you're all the way down to here. Then you'd have all of that to go through. Okay. So let's go ahead and look at, how about we just do calcium? Okay. What's the next lowest noble gas down in number as opposed to calcium's element 20? Argon. Okay? So you have to pick a noble gas, and it has to go down. Okay?
How do you know that it's argon?
Because I can't.
Okay. It has to be lower than 20. You can't use krypton because that's going up. You have to go down. Okay?
So you can use neon or argon.
Would it not be potassium?
Let's go.
No, it has to be
Nick, go.
How do you know?
I think that's a good place to stop. But I don't know. We can pick up with this tomorrow. Or do you want me to finish this or no?
Yeah.
What's your question?
Noble gases are black.
So you could use neon or argon.
Look at your
As long as you're going down, it's just easier.
I would say use argon. Okay. What period is argon in?
Third.
Okay. So we said you had to go down in number, right?
Yeah.
Okay. So 18 is smaller than 20, right?
Yes.
Okay. So you said correctly that argon is in the third period, correct?
Yeah.
Okay. So what comes after 3p6?
4s2.
What's 2 plus 18?
20.
Okay. What period is calcium in?
1, 2, 3, 4.
What period is calcium in?
4.
That's where that number comes from. What block is calcium in?
The S block.
Now, what column in the S block? That's where all those variables are coming from. That's why we say this is such a repeating pattern over and over and over again.
Period, then block, then.
Yes. Okay. Left outside and the left middle.
Yeah. Shake your head.
Left outside and the left middle. Okay, middle. Right side.
4 is the period, and S is the block.
Right side. Right side. Okay. All right, we'll catch up with you next time.